So when we're predicting outputs based on something called interpolation, what we're really doing is using a really old methodology called the Cartesian plane, which was initialized by René Descartes, a mathematician and philosopher. So what we're going to do is we're going to use interpolation, or the Cartesian plane, for both of these questions. The first question reads, what's the volume of water at 5 seconds? So here we have volume of water per time. And I guess the scenario would be something like it's dripping or whatever have you. It doesn't really matter. But what we're going to do is, to figure out the exact volume at 5 seconds, we're going to go to 5 seconds. And we're going to draw a dotted line up from 5 seconds until it actually hits the line on the graph. Now this line would have to be given to you. If it's not given to you, you have to make the graph, and you'll see that in our third example. So I've drawn the dotted line up until it made contact with the line. And then from that line, I'm going to draw a direct straight line to see what value it is on the y-axis. And I could see that it's 5 milliliters. So then we could say that at 5 seconds, the volume of water is 5 milliliters. This whole process here, the building of the Cartesian plane, this is interpolation. Now in another color, we're going to answer B. Let's say in green, when will the volume reach 5 or 7 milliliters? Well, we're going to go now at 7 milliliters, and we're going to draw a horizontal line, a straight horizontal line. Now this should be done with a ruler until you make contact with the line already drawn. Once we make contact with the line already drawn, then we're going to extend the line again with a ruler downwards until we cross the x-axis. And we see that that crosses at approximately, I'll make the approximate symbol, 7.3 seconds. So again, the building of these Cartesian planes is called interpolation. So let's say instead of having a line already present, we have a series of points. And the question reads something like this. If 9 tickets are sold, how much profit will be made? So we have profit as the, you could say, the dependent variable, and the number of tickets sold as the independent variable. So the first thing that we're going to do is we're going to make a line of best fit. So that's really a line that from the first point hits as many of these points as possible. Now, some might ask, well, why don't you just draw a line that connects all the dots? Well, if I do that, right, it's not a straight line, look. Okay, so we want to represent a linear function with a constant predictable relationship. So we're going to make a line of best fit. Now, what the line of best fit is from the first point, it's a line that hits as many of these points as possible. And yes, there's going to be some guesstimation that happens, and that's okay. Any point that is outside, we call these outliers. So here's an outlier, and this is another outlier. But this here, the line, and I'm going to bold this right now, this line is what we're going to actually be working with. The next thing we're going to do is we're going to interpolate the line of best fit, which is we're going to make the Cartesian plane. Now the question is asking about 9 tickets. So what we're going to do is we're going to go to 9 tickets over here on the x-axis, and we're going to make a dotted straight line until we hit the line of best fit here that we're going to work with. And then from there, like we did in the previous 2 questions, we're going to make a straight line or a horizontal line until it crosses the y-axis over here. And so based on where it crosses the y-axis here, that's how much profit will be made. And we can see that it's approximately about $6.5. So lastly, for this next one, how long will it take for the gas volume to reach 13 milliliters? So we have gas volume as the dependent variable and time as the independent variable here. And so like we did with the previous question, the first thing we're going to do is make a line of best fit. And that's going to be a line from the first point, and then it should extend through as many points in this data set as possible. Okay, so it's touching 3 points. So again, here, anything here, these are outliers. Okay, so now that I have my line of best fit, I'm going to use interpolation with that line of best fit, or with that line, that purple line that I've drawn, and then that's going to give us the answer. So I'm going to go to 13 milliliters, which is here. And then if I use a ruler, and I'm going to put a ruler here, at 13 until I cross that purple line. Then I'm going to drop it down to the x value. And again, you should be using rulers for this. And when I do that, I see I have a value of about 15. So it should take about 15.0 seconds, and do the approximate sign, to reach 13 milliliters here. Now again, for those that are still struggling with the line of best fit, what the line of best fit is it's a line from the first point that hits as many points as possible when it seems like you cannot make a straight line data from all the points given, but we want you to use a linear function.